Hi, this is Mr. Word. This is my third video for us to talk through how to deal with some of the kinds of problems you'll end up with on 7B. So I've dealt with problems like these already, this sort of thing, but now I'm going to start dealing with problems like these. This is the 4A. Actually, really just one like this in here, I believe. That's correct. Just the one at 4A. That's a 4-term polynomial. So you'll need to factor by grouping. There may be some greatest common factors that you can pull out. And let's do this. So here, what I'm going to do first, the very first thing I would do is I'm going to pull out any common factors everything has. And there's an obvious one in the beginning, which is 10. Okay, so I'm going to knock this down to a 0. Knock this down by 10, Knock this down from 15 to 35, or from 350 to 35. Knock this down from 180 to 18, and knock this down from 420 to 42. So I have done that first thing, and that's going to make my life a lot easier when I start doing the factor by grouping. Now I will factor by grouping because I do not have any further factors I can pull out. So I'm going to group these and these, and I'm going to put parentheses there and a parentheses here because these two groups are within one big group. Okay, let's start pulling things out of these. On the left grouping, I can pull out a 5x squared. So I'll get an x squared out of this, and both of these share a 5. So 5x squared. So that just becomes 3, and that just becomes x. This just becomes 7. Okay, let's look over here and see if we end up with something similar. So I can't pull any x's out, but I can pull a 6 out of both of those. So I pull a 6 out, this becomes 3x, and this becomes 7. So look, I've got a 3x plus 7 in both places. And that 3x plus 7 is going to be shared by 5x squared and 6. So I'm going to create a new binomial here. Get rid of that one since we don't need it twice. And now I don't need the outer parentheses anymore because I've factored everything inside. It is possible to take the 5x squared plus 6 another step, but you have to step outside the so-called real number system into the complex imaginary number system. You'll be learning a lot more about that in Algebra 2 when you get there. This is the square root of -1. But if you're curious about how the heck that works, this is the same thing as minus -6. And once you've got this structure, we could organize this into a difference of squares structure as long as we're willing to deal with the so-called imaginary number. If you're curious about that concept and would like to know more, check out a video series on YouTube called Imaginary Numbers Are Real. It gives a nice introduction in the first couple videos and then goes out on the skinny branches with some pretty wild things. It's quite interesting, worth checking out. I go back and watch it periodically. Okay, it's put out by a group called Welch Labs. So here we go. I'm going to actually write that into the chat, into the notes here, not the chat. Okay. YouTube series by Welch Laboratories. Imaginary numbers are real. 13 video series. Okay, let's do this one. Now we're going to first find any common factors and clean those out. And I look through here. Everything is even. That's one thing that's very clear to me. So I can pull a 2 out of the whole thing. So that would become a 30. That would become a 100. That would become a 33, -33, and that becomes a 110. Okay. And I don't think we can go any further with greatest common factors of everything, but we can find some stuff when we pair these up, because there will be some factor by grouping that we can do. So I'm going to put that negative on the inside of this other group, because that'll help me keep track of signs. Okay, so I've done that. Let's go to the next cell and start pulling things out. So I'm going to pull out, I can definitely pull out an x squared here. So I'll pull out an x squared, and that drops that just to an x. And that drops that x squared into a 1. And now I can pull out a 10, and 30 becomes a 3, and 100 becomes a 10. Over here, there's definitely some sort of 11 business happening. Since I ended up with 3x minus 10 over here, I kind of want this sign to change. So I could pull out an 11, but I really want to pull out a negative 11. And when I do that, that becomes a 3x, and that becomes a minus 10. And now I have a 3x minus 10 shared by the 10x squared and the negative 11. Okay. Let me copy this one more layer. And so I'm going to take this 10x squared, add it here, create a parentheses, and put it here, because I can, and I'm going to get rid of that one because we've already using it. Now, this one can be taken one more step if you're willing to deal with radicals. Now, I didn't give you any like this where you'd have to deal with radicals, but this can be treated like a difference of squares. And here's how we would do it, just for your future reference. We would turn this, we can definitely get a square root of x, but then we need the square root of 10. We're going to say x, and that's going to be minus the square root of 11. And then we'll copy that. And we also need the plus version. And that will definitely multiply out to be this, 10x squared minus 11. Play with it if you'd like to check it out and learn more. Let's do this one, though. So I'm going to copy it. I'm going to factor out the largest thing I can factor out of everything, and that appears to be an 8. I can get an 8 out of all parts of that. So that becomes just x cubed. That becomes 2x squared. That becomes 3x. And that becomes 6. And now I will see if I can factor by grouping. And so I'm going to group that and group that. And it does look like I can factor by grouping. There is a pattern that I'm seeing in here. I'm seeing a 1 to 2 pattern, and this is also a 1 to 2 pattern with the 3 and the 6. So that tells me I probably can do that. So I'm going to pull out an x squared on the left. And that drops that to just x, and that gets rid of this x squared, because x squared divided by x squared is 1. And over here, I can pull out a 3. And that becomes just x, and that just becomes 2. So yes, I am sharing the same factor of x plus 2. And I can reorganize my grouping like this. And that goes away because it's already taken care of. And once again, we could factor this further if you're willing to work with complex imaginary numbers. I will demonstrate how that could be done. This becomes minus negative 3. Desmos will get a little mad at me when I do this, but that's okay. What I'm going to want to do is get this is a difference of squares structure. So I'll have x minus, the square root of negative 3 is going to be the square root of 3 times I. Okay, and then I'm going to do the same thing. I is the square root of negative 1, and I'll say plus. And I actually have factored that completely. I can drop out the outer parentheses. You won't have to do that for any of the problems, but I wanted to show you how you could. All right. If you're curious about that, once again, Welch Labs, imaginary numbers are real. There it is, YouTube channel. I'll actually go there. Okay, and videos. And here's the first one from Welch Labs.
Grammarly can help you rate
there's the
quickly and
Grammarly ad, of course. But here it is. This is the oh my goodness, more ads. This is Welch Labs, though. I'll go to Welch Labs directly, and you can find it right here. Go to their playlists. A lot of interesting things. But this is the playlist called Imaginary Numbers Are Real. Enjoy. I hope you were helped by these series of videos.